Okay, in this exercise we will look at Introduction to Numbers, number sets. State which of the following sets the following numbers belong to. So we have 12 numbers here. 18, 0, minus 6, square root of 25, 17 divided by 4, 1.333, ... which is sort of presumes more threes. 4.25, 15 to the base 10, 8.2347 ... square root of pi, and minus 11.132. Okay, so the possible answers to this question are as follows. So the set of all real numbers, okay. Now, as far as discrete mathematics is concerned, this is usually as far as we go. But actually, in more advanced mathematics, there are complex numbers and so on, where that will be the real number set will be a subset of another number set. But as far as discrete mathematics is concerned, this is as far as we will go. So we have the real numbers, which essentially all numbers, essentially, that at a practical level you will be encountering in a discrete maths course. Rational numbers, Q, and that is called blackboard font, by the way. So you see the Q, the R, and the Z, and the N there. That's a special notation called blackboard font. Anyway, Q is a subset of R, okay. Q stands for quotient, which is essentially means that rational numbers, essentially the quotient, are the fractions of integers. Okay, so one integer divided by another integer, that will yield a rational number. Okay, then we have integers themselves. We denote them Z, which comes from a German word that escapes me right now. All integers are essentially can be considered rational numbers, and all rational numbers can be considered real numbers. Okay, so Z is a subset of Q, which again is a subset of R. Now, natural numbers is essentially numbers like 1, 2, 3. Now, it's the counting set. Just a little caveat on this. I'm sort of taking a very traditionalist point of view about natural numbers, the counting set, in that I won't include 0 as a natural number in this exercise, but some people might dispute that. So just watch out for that. Okay, it's essentially the numbers you use to count, like as if you were in school for the first time. That C with an underline under it is notation to signify that something is a subset of something else. So if we go back to the natural number line, the set N, which is the set of all natural numbers, is a subset of Z, which is the set of all integers, which again is a subset of Q, which is the set of all rational numbers, which again in turn is a subset of R, the set of all real numbers. Anyway, so we'll move on. And let's go through these very quickly. So first off, we have 18. Yes, it's a natural number. So that means it's an integer, a rational number, and a real number. Okay, by default, it's a positive integer. Okay. Now, going down to 0. Just as a caveat, or just to recall my caveat that I was sort of saying that I'm not counting that as a natural number as part of the counting set. It's definitely an integer, though. But so I'm going to start with integer, and that means it's a rational number and a real number. Some people may dispute this and say it's a natural number also. I have to sort of make a decision on that, and I'm going with the traditional point of view, which says no, but really it's just a point of view. So, minus 6. Well, it's definitely an integer, but it's not a natural number because it has a minus sign in front of it. Okay, so that's what we're going to say with that one. It is an integer, and therefore also a rational number and also a real number. Now, the square root of 25. Well, the square root of 25 is 5, and that is an integer and a natural number. So we're going for yes for natural number, yes for integer, yes for rational number, and yes for a real number the whole way through. Okay, so it's the same answer as 18 at the first exercise. Okay, so the next bunch, 17 divided by 4. Well, that's an integer divided by an integer, so that makes it a rational number. It's definitely not an integer in its own right, and it's definitely not a natural number. So rational number and real number, yes and yes. So it's an element of Q, which is an element of R. Okay. So 1.333. Well, that's a repeating decimal equivalent to 4 divided by 3. Again, an integer divided by an integer, so that's a rational number and also a real number. Okay, Not an integer in itself, not a natural number in itself. 4.25, that's a terminating decimal. Terminating, so you sort of say it's a clean cut, so to speak. There's no dots afterwards. So that's equivalent to 17 divided by 4, which previously we decided was a rational number and an integer divided by an integer, and hence a real number. Okay. 15 to the base 10. Well, essentially what I'm getting at here is that it's just 15. Okay. So it applies to all sort of number systems there. This setting, putting numbers into these sets. Okay. So 15 to the base 10 is just a decimal representation of 15. So it's a natural number, integer, rational number, and real number. Now, so here's the last bunch here. 8.2347, and we're going to assume that's a non-terminating, non-repeating decimal. Okay, there are such things as repeating decimals which can be expressed as fractions of two integers. So you just have to watch out for that. I'm not going to deal with it in this exercise because it's a little bit complicated. So that's a real number, and it's not. We are assuming that this could not be represented as a rational number as a fraction of one integer divided by another integer. So it is just going to be a real number. We have pi and the square root of pi, and in both cases they are irrational numbers, and which is to say they are not rational numbers. They cannot be expressed as quotients of as one fractions of two integers. So in both cases they are real numbers, and that's all we are going to say about them. Minus 11.132. Well, that actually is a rational number. So you can express it as 11,132 divided by 10,000. So the three decimal places there does not exclude it from being a rational number. Okay? So just watch out. That's the difference there between, let's say, exercise 12 and exercise 9 with the dots there afterwards. So it is a terminating a decimal. Okay. So that means it can be expressed as the one integer divided by another integer. Very big integers, but integers all the same. So it's therefore, it is a rational number. And if it's a rational number, that means it's a real number. Okay, we'll leave it there.